In this video, we are going to do the same example problem but with 4 elements this time. I'm going to keep everything intact. This video will go much faster because you already now know how to set up the problem. So I'm going to do the exact same steps. I'm going to make a curve. This time, instead of making a single curve, I'm going to make it into 4 parts. So I'll say I want to make the first curve, which is going to be of exactly 1/4 the size. So I know that the dimension is 62.5. Then I want to make the second one where the starting point will be 62.5, but the end point will be 125. Then I want to make a third curve where the starting point will be 125, the end point will be 187.5. But you could also very easily create these points and then just join them together like dots. And the last point is going to be with 187 to 250. If you keep reading at the bottom, you will see that all the lines have been created correctly. So I have 4 curves here. Now, after these 4 curves are created, I have to go back and again assign properties to it. So I'm going to create a isotropic material just like before. It's the exact same material. I hit apply. Then I have to create properties, and I'm going to use 4 different properties this time. So the first one I will call truss 1. The commonality in all of them is the material. The only thing that changes throughout is going to be the area. So if you look carefully at all your calculations, you'll be able to find the correct areas, and this time you can select application region as particular curves as they come to where they will be applied. So that was truss 1. In truss 2, the area is going to be changed, 117.19. This would be applied to the second curve that you can pick here. You add it and you apply it, and you keep doing the same till you have applied the correct properties to all the different truss elements one by one. Don't rush the first time you do it because you want to make sure that you have understood everything and you're applying all the different properties. So don't just watch these videos, but also work with me alongside. If you want to pause it and work out the problem or rerun something, please go ahead and do that instead of watching it completely and then making it yourself and having made some mistakes, because the first time it's quite crucial that you actually get a grasp of what buttons to click and where to click them, where to find them, those kind of things. And of course, never forget apply. So all the properties have been created and applied to the curves. We can create the same boundary conditions as we did before. So I'm going to create the fixed boundary condition. Please be aware that you could have used the exact same model as we did before and just made some modifications. It was my choice to start all over again, just to give you a certain idea of how these things are done. But there's no obligation to do it the way I am doing it. You can always do it the way you would like to do it. You can make backups, you can make copy of model, however you want to work with it. So this is just the way now I'm going to create the force. After creating the displacement, this time I don't write zeros but just the commas. You will see that it works in the exact same way, and I wasn't really lying about it. This is of course at the end of the curve 4. So you see this time it's not 1.2 but 4.2. So my load is applied, and now what I need to do is I want to mesh. In this case, I want to create a mesh seed, and every length of every curve will have just one element. And in this case, I can just select all the different curves, and you will see each curve is associated with one element. Then I can go to mesh seed and I can curve each of these meshes. I don't have to select properties because those are already applied. Everything else remains the same. So I'm going to select all the curves. So it shows curve 1:4, so 1 to 4. And I hit apply. So 4 elements are created with 8 nodes. Now, this is a bit strange, you would say. You have 4 elements, but you have 8 nodes, but actually they're common nodes. So this is one step in PATRAN that you should never, ever, ever skip. Always remember that you have to hit this button called equivalence. Once you've created a mesh, what PATRAN does is that all the elements are created individually. So they all have their own node. So if you look carefully, this will be node 1, 2, and again there will be a node 3, 4. And a node 4, 5, 6, and a node 7, 8. But all these are common. The 2 and 3 and the 4 and 5 are just common. So you need to get rid of the common nodes. So what the option equivalence, which also lies within the meshing button, if you go to action equivalence, does is that it's going to look for duplicate nodes which are present very close together. So the equivalencing tolerance is 0.005. So if they're really, really close to each other, then it's going to remove them. So if I say preview, it shows these pink circles here, which means here there are common nodes which are overlapping each other, and you know that's true. So what you can do is you just hit apply and it will say equivalencing is completed, 3 nodes were deleted. So if you had 8 nodes before, now you're left with 5, which is exactly what you are looking for. So you've created your model now, you've completed equivalencing, which is very important before you go into analysis if you have more than one element like you see, and they have common edges. So your model is ready. You go to analysis and you create a new model. Let's call this 4 element. And we're not going to go through any of those because those remain the same, as you might remember. And I just hit apply. It gives me an error this time. It says some elements in the model have no types or properties defined. Do you want to continue with the transition? And I say absolutely not. So if you remember, I had applied some properties to the geometry. Sometimes PATRAN gets a problem when it has to make elements, then it does not take the property into account. So in this case now, we need to apply the property to the mesh. This is going to happen often. So yeah, this is a big pain. It's a problem, but there's some things you have to deal with. So we just go to creating the mesh, or we can first of all delete the mesh completely. So we say, let's just delete the mesh. And everything related to a mesh has been deleted. We are going to create the mesh again, and this time instead of creating the mesh for all 4 curves, we will do it one by one. So we say, okay, we have curve 1 and the existing property would be truss 1, and then we hit apply. So we have 1 element, then we do curve 2. You can select existing property to be 2, apply, and you do the same with the rest of the curves. This is indeed a property. This is indeed a problem, and there's no solution so far. So this is the only way of getting your work done. So you see that now you have 4 elements that have been created, but of course you need to go through the step of equivalencing again. And 3 nodes are deleted at these pink locations. So now your model is ready for analysis. We can go back to the analyzing phase and we say, okay, run. And this time there's no problem and it starts running because there are boundary conditions, loads applied, etc. It has finished running, so this time I can just do plus XTB and hit on apply. And you would see that I have attached the results file to have results. Let's open the results and have a look at the quick plot where I want to see the displacements in fringe and in deformation. And I see that for some reason I'm seeing constraints as well because it was both selected. Let's clean up this file, and now we say, okay, let's have a look at this. This is pretty weird because it keeps showing me the constraint forces. And this is some kind of a graphical glitch I'm expecting. So let's go to fringe instead and let's look at the displacement. Yeah, indeed it is a graphical glitch because it won't move beyond a certain value. So you see that the maximum displacement is 3.47 10 to the power minus 2, which is different than the result with 1 element. And here you can actually pick nodes. So let's say we want to pick particular nodes, and we can say create a fringe, or let's say create marker plot for a particular node. So I want to pick up nodes and I select node 1 or node 2 and I hit apply, and here I see the displacement in the x direction. And in this way I can also pick up different nodes. So I can say I want to add node 4, I also want to add node 5 or 6 or whichever ones, and then you see different displacements at the different points. So this way you can pick up the different nodes and have a look at the results. So where is it exactly? You have a create deformation or create fringe or create marker, whichever option you want to use. And in this second option where it says target entities, you click there and here you'll be able to pick up certain things. So let's say I want to target elements, but for the elements I want to see the stress, right? And in this case I want to pick this element and I say apply, and I will be able to see the stress in this particular element. So there is apparently no stress. It's probably picked up the wrong, yeah, this is the wrong quantity. So I just want to pick up the component and I say apply, and I see that the stress is about 10.2 megapascal. So these are also different options you will see. So for the stress, you will have principal stresses, you'll have component stresses. So you'll be able to pick up particular X, Y, Z or something else as shear. So there are different options which you will be working with slowly, steadily, as you have different examples to follow. Now what I want you to do at the end of these two exercises is to actually compare the results from both the models. You had one model with one element, one with four. Now you will see the differences in numbers that you get for displacements. Why is that difference happening? Think about that. Let's discuss that. Let's put it on the discussion board. Would you think this is close enough to the exact solution? If it's not close enough to the exact solution, what can you do to get close enough? What would be the best way of reducing this error between the exact solution and the results that you get from finite elements? And this would be something you'd be able to check with the exact solution, the finite element formulation with one element, and the finite element formulation with four elements. So please critically think about what are the differences, how you can reduce the errors. And that's something I want you to take from these two exercises, not just how to click the buttons and where to get your results from, but also how can you make your finite element model better.